Hello everyone. Today we are gonna implement basic transformations like scaling, rotation using the transformation matrix. So let me show you the output first so that we can understand the code easily. The output has four parts: the first track, second curve, and the third track, and the lake in which the reflection of our main object would be shown.
So now we are seeing the Python code for this transformation using matrix method. So if we are using matrix method, so we have to define the matrix multiplication function, which takes x and y two matrices as the input and multiplies them and returns the result of result of the multiplication. It will get the dimensions of the both matrices and then check if the multiplication can be done or not. Then it will iterate for each rows and columns and store the result and return it.
Now we are going to define the class. Now here we define the class of the car, which is basically the initialization of the car takes place. In this, we take a normal point P, and we define a polygon using all the point that are calculated using this formula. Same is for the wheels. According to the point P, we take out the value of the dimension of the wheel, and here we define the draw function and the undraw function, which would be used below for the movement of the car. And now we are basically making the transformation, defining the function for the transformation which will be taking place in the polygon and the wheel, in which the p old are old points, and the p new is the multiplication of the transformation matrix. The transformation matrix, which is, for example, like for scaling it is different, for rotation it is different, and we'd multiply that matrix with the p old. And then the same values, the values of px and py are changed with the new values which we have got from the multiplying the matrix, the transformation matrix, and the p old. Same is done for with the wheels.
Then in this function we use the matrix for transformation, but how we got the matrix is then using these functions. If you want to get the matrix for transition, you can pass the parameters of transition in x, transition in y, and then calculate the matrix using this formula. This is simple, but for the rotation there is a pivot point also. So you have to first change your origin to that pivot. So we have to transform the transition for of minus pivot x and minus pivot y, then apply the our rotation matrix, then again the transition to again put it on the previous point. So it will return the transition matrix, the compound transition matrix, which will be very efficient as it is not computing the whole matrix again and again, instead only once. Same for the scaling matrix, the pivot point and the main matrix. But in this scale, we are as if we are using circle, we have to change the radius also. So this function will change the radius, and for the reflection, we can simply invert the x and y value. If we want the reflection in the x-axis, we can just change the y value. So we will pass -1 here and 1 here. So it will be the reflection we will use in our explanation.
We will be basically starting the movement of the car and the making of the track. We first draw the car on the point 0, 200, which we would be somewhere like at this area. Then we will draw the track. The track would be from point 0 to 200, which is this point, to the point 180 to 180, 155. So basically, the car would be moving for 180 on the x-axis. Then we draw the curve. The curves are drawn using parametric equations, which are given over here. Then we will start the movement of the car. As I explained before, the car will be moving for 180 in the x-axis. Then we would also be taking out, as the car is on a particular slope, we took out the slope using the we took out the slope as 0.25, and we calculated the area using tan inverse angle using tan inverse 0.25. And now we basically start the movement of the car. The car gets its transition matrix from the matrix which we calculated above, and then we start the transformation. We take this as sleep time for 0.01, because if we do not take this, the car wouldn't you would not be able to see the car uh, uh, moving in this. But this basically says that the car would be drawn and undrawn every zero. First it will undraw the old first car which was made at 0, 200, and wait for 0.01 and draw the next car. For the alignment of the road, we just aligned the coordinates of we took a rotation matrix and the angle which we took out using the tan inverse 0.25, we just implemented in the car polygon, so the car moves in aligned when it is aligned with the car road.
Road. So after this simple transition transformation, then it will rotate. So the rotation matrix will be used. We are defining steps as 90, and then the angle which is by which it is rotated is pi by 4. The angle change per iteration will be angle by steps, and the transition matrix for the rotation will be calculated by this function, which was defined earlier. Then it will iterate for steps, number of steps, which is 90 in this case, and then it will transform the matrix using this transformation matrix. We can The transition matrix is calculated only once, and the transformation is applied iteratively. So it will be very efficient because the matrix is not calculated in every iteration. Instead, it is already calculated once, but using in every iteration. Then it will wait for 0.01 seconds and then draw and undraw it. Then it will align the car with this slope, and the movement 3 is transition and reflection both at the same time. For the first part, which is just for transition of x by 60, it will move near the lake. It will be same as previous one, but for the step in which it is near the lake, the reflection should also take place. So we are calculating another transition matrix trans1 for that reflection purpose. You can see that we have set the value of y as -1 because we need to uh, get the reflection about x-axis. So here is the pivot. It will be around reflection will be around y equal 220. So it will look like the reflection is on the lake. So it will transform the car to move for the transition, then undraw it and draw. Then it will wait for 0.007 seconds. Then it will transform using trans1, which will transform it for the reflection. Then it will again draw it. So the same car will be first drawn for the normal image, then for the reflected image. So and after this, again 250 steps for reaching the car from here to here. As you can see, for the output, when it will reach near the lake, you can see the reflection, and then it starts again moving. And you can see also, like, the car is always aligned with the road because we rotated it with the given curve. Thank you for watching.